Hi, good evening. Can you hear me? Hello. Good evening. Can you hear me?
Hello, sir.
Yeah, how are you?
I'm good. Good evening.
Good evening. Yeah, so after a long time we'll meet. Okay. So hope
Yes.
everything is
Yeah.
good from your side. Yeah.
Yes. Yes.
Okay, thank you. Okay, so let's go. Today I discuss about that another agriculture precision topic. Mainly you already sent me a paper about the crop coefficient. Okay, how we can easily identify.
Yes. Sir.
I try to discuss about this topic, how we can easily identify the crop coefficient using the linear model. Okay, then you can easily get the idea. Okay, so let me share my screen. Just a minute. Okay, can you see my screen? Is it visible?
Yes, it is coming. Maybe.
So basically today we discuss about this topic, how to monitor the water demand of crops to estimate the crop coefficient using the Google Earth engine. And basically when you work with the crop coefficient, then first of all we need to create a model. It's called the linear model. In the linear model we just make the relationship with vegetation density, different types of crop, and further we can easily identify the crop coefficient. And this crop coefficient is very important in the agriculture precision, because if the this value is the high, it means that this type of crop need the water demand is very high. Okay, if the coefficient value is low, it means that water demand is not high. As well as we can also get the agriculture irrigation schedule, we can also identify using the KSE value. Okay, so let's try to explain all of those step by step, then you can easily get the idea. So there's a lot of application such as special irrigation scheduling. We can easily get the idea, the scheduling about the irrigation, and also water use efficiency assessment. We can also identify, and also crop water requirement estimation. We can also do, and also integration with the ET models such as CBEL or metric or SSE, BOP. This type of model we can also integrate with the KC value. Okay, so basically, in the interpretation, suppose for the NDVI map, it's a vegetation greenness. We already know about that. It's a vegetation greenness. Or we can also say that it's one kind of crop density. Okay, suppose I have a crop field. So here I find out some place is the high NDVI value. It means that this place I find out the very high density of vegetation, or vegetation greenness is very high. Okay, or what is the KC? KC map basically it estimate the water use coefficient. Okay, KC map it's estimate the water use coefficient. Higher KC value equivalent the higher evapotranspiration. Okay, so if the value is very high, it means that the higher evapotranspiration. Okay, for this place. For the sparse crop, suppose we have the low NDVI value, suppose 0.2 or less than 0.1 or 0.1. This type of low NDVI value or sparse crop, this KCY value is low. We find out the low KCY value. It means that this type of crop is not high evapotranspiration. It's a low evapotranspiration. And if the low evapotranspiration, it means that they are not much need the water. Water demand is low. Okay, same just opposite for the dense canopy. Suppose I have a high or good crop plant or good density of crop plant. So here I find out the high NDVI value, suppose 0.8. If the NDVI value is very high, then KCI value is also high. Okay, because in the high NDVI value or dense crop plant have the higher evapotranspiration. Okay, suppose I have a good field or I have a good crop plant. So this type of crop plant I find out that high NDVI. Okay, And if the NDVI value is high, then KCI value is also high, because high NDVI value or dense NDVI or dense canopy, this type of place I find out the higher evapotranspiration. Okay, so high KC value indicate the full canopy or high water demand crop. Okay, suppose I just calculate the KC value, and this KC value I find out some place is very high. It means that this type of cropland needs the high water demand. And if you check, this is the formula about the KC. Okay, so here we find out that you can see this is the first formula, ETC equal KC multiply with the ET. So here ET basically crop evapotranspiration. Okay, and also ETC basically crop evapotranspiration. Then ET0 basically difference evapotranspiration, and KC basically crop coefficient. So now we can simply calculate this equation, Kc equal to crop evapotranspiration divided by reference evapotranspiration. Okay, just we simply just ratio of the crop evapotranspiration and also reference evapotranspiration. Then we find out the result of Kc. Okay, so this is the basic equation for the Kc. Okay, but when you create in the remote sensing we try to apply the linear model. So we simply find out the KC and also NDVI relationship in the linear model. Okay,
Sir,
yeah, please
please.
Please.
That crop evapotranspiration is actually obtained from the weather data, from maybe the what is this, the teleclimate, or from
Yes,
the modis.
yes.
Crop.
Yeah, so
Is that, and what
anyone
now
we can also use, no problem. Okay,
and it is zero difference evapotranspiration.
Yeah, it can be come from your weather data. Okay, suppose ER5 reanalysis data we can also use for the as a reference data, no problem. Okay, so there are the two.
And the crop
Yeah,
what is the difference now between the crop evapotranspiration and reference evapotranspiration?
okay, crop evapotranspiration basically for the crop, only for the cropland. Suppose the cropland just transpiration from the water. Okay, suppose we already know about that. If you check, I will show the some example, then it will be more clear. Suppose if you simply search here,
Yes.
the transpiration it's only happened for the cropland or agricultural land. Okay, transpiration, suppose transpiration in plants. So you can see this is the example about the transpiration. You can see, so this is the plant. Okay, this plant also you can see transpirate some water. Okay, transpirate some water. So it's called the evapotranspiration. Okay, only for the trees. So this is the tree. So this tree also release some water. You can see this tree is also release some water. Plant surface with stomata storage some water. So this water release. Okay, and it's one kind of your hydrological process. Suppose transpiration. So this transpiration is only happened for the plant or trees. So you can see this type of plants, this type of tree release the water. Okay, it's called the transpiration. And when this transpiration simply connect with evapotranspiration. Okay, so it's one kind of transpiration only for the trees. But another evapotranspiration is also happened. Suppose for the weather, from suppose ocean or normal water body or river or lake. So this type of place also evaporated. Okay, and also release the water, just make the condensation. Okay, so this type of water evaporate and make the condensation.
Now my question is,
yeah,
is there any satellite data source for crop evapotranspiration and reference evapotranspiration? Because I know the MODIS and teleclimate maybe they give the actual evapotranspiration ATC. So actual evapotranspiration can be used as a reference or can be used as a crop evapotranspiration. Or there is a way to extract the actual transport, to extract the crop evapotranspiration and reference transpiration from actual evapotranspiration?
Yes, we can also get it from here. Yeah. Suppose in the satellite, if you check, we find out this type of satellite. Suppose one satellite, you simply search here. Suppose Moody's
Yes.
evapo. So you can see Terranet evapotranspiration and also Aqua. So I simply search that Terra, and here we find out that you can see this is the ET
Tot-
mainly total
it-
evapotranspiration. Okay,
Yes.
total evapotranspiration. And this also you
Yes.
can see we can get the average latent heat flux. So this is the LE, and you can see the total potential evapotranspiration.
Yes.
Okay, PET. So this type of evapotranspiration you also get from here. Suppose I can say this is total evapotranspiration, and also again the potential evapotranspiration. Okay, so when you just subtract these two things, then you can get the another evapotranspiration. Okay, we also get also the data from generate also from here.
Oh,
This type
okay.
of data.
Okay.
Yeah. As well as also get the some data. Suppose it's called the ER5 reanalysis data. But this data mainly it's not good resolution. Okay, it's a very, so when you want to
Yeah.
work with the large area, then we try to use this type of data. But for the Modis, we can also use for the small area because Modis is more better than ER5 reanalysis data. We can also apply, no problem.
Okay.
Okay. So now we simply generate this type of formula.
You can remove this, the pop-up window, the small pop-up window here. Yes.
Okay. So here we find out that basically EC or KC basically crop evapotranspiration divided by reference evapotranspiration. And this reference evapotranspiration we can also get from different sources. If you want, you can also use it at the satellite source, or if you want, you can also use it at the weather data. We can also collect the data. You can see that also put the one example. So in the paper he should send me, they use the Penman Montreal. This is one kind of source for the weather data to collect the reference evapotranspiration. They also collect from here. And then KC basically crop coefficient. Okay, this is the formula about that. But in this case, we try to make the relation with our crop. Okay, suppose, and how in this case we apply the NDVI. Suppose I want to make the relation KC and NDVI. Suppose I have a value KC and NDVI. So now here I just apply the linear equation y equal to mx plus c. Okay, y equal to mx plus c, and then identify the Kc equal to, identify suppose slope value, it's a slope value, and it's a intercept value, y equal to mx plus c. So when I just generate this equation, then we can easily get the Kc equation. Okay, so this Kc equation is simply multiply or connect with the NDVI, basically simply multiply with the slope value and also intersect with the intersect value, simply add, then we can get the Kc map. Okay, on how to build your model. So now we talk about that. Suppose how I can build your own model. Suppose in this case we can get the NDVI values from satellite imagery. Observe the our crop field. Suppose I have a crop field, so I can simply get the NDVI values for my crop field. And further, Kc value, in the Kc value you can also get the ground measurement Kc value. It also possible, we can also monitor the Kc value from the ground, from the ET data, or you can also use the table. You can also say in your paper the FO56 table adjusted for your condition. So if you check this paper, they also use it. This paper, this is the formula Kc estimated from this. Okay, and you can see from the FAO table they also get this data, and this is the formula. Okay, etc equal to et. ET into KC. So from here they find out the KC value or coefficient value, and you can see they also get the KC's ratio of the ETC. Okay, and the United Nations Food and Agriculture Organization established the table of KC for the different crop. Okay, so it's the established data. Okay, so we can easily use it for our any this data because it's provided the Food and Agriculture Organization or FAO. Okay, they are already provide some table KC data for the different crop. Okay, which is considered an important tool to estimate the KC. So now we can easily get, suppose I have a rice, I have a corn, I have a paddy. So they are also give this type of crop plant, a specific crop plant, they give the KC value. Okay, so now suppose I already have the KC value and I already have the NDVI value. So now what can I make the process? So we are just make the linear model. We just create the linear model. And how I can get the KC value? KC value, it provide the Food and Agriculture Organization established table of KC for the different crop. Okay, we can get the data from here and then we also use it for our specific crop. Suppose in this case there is the location area. So this is the crop plant. So in the crop plant they have, you can see the wheat, potato and sugar beet. So this type of crop plant, so this type of individual crop have a different KC value, and this KC value they collect from the Food and Agriculture Organization established data set. They are also collect from here. So now further they are make the linear relationship and make the analysis. Okay, so now how I can make the relationship about that. Okay, we'll also discuss about that. Then you can easily build your own model. So in this case our main target we try to create. So you can see they are put the this type of value. So for this time they get the NDVI value and also get the KC value for the wheat for the different times, sugar beet and potato field. They also get this type of data. So now this type of data they are used and make the relation. You can see in the relation basically this is the slope value and this is the intercept value. Just simply apply the slope and intercept value and then make the model. Okay, and then make the model. So now they are use this model and make the KC map. Okay, so let's go try to discuss about the how we can easily create this. Also you can see this is the linear relationship about this model and also calculate the R square value relationship about that. Okay, so let's go try to discuss about that how we can easily create this type of model. So now we can easily use here the Python because we can easily apply the linear model using the Python for the two data set. Suppose in this case NDVI and KCI value, we simply apply this model and make the linear model or linear equation for the NDVI and KC value. So let's go. So for that, okay, let me open my code editor. So you can easily use at the just open your terminal. Okay, let me open from here.
Sir,
Yeah, please.
in that terminal, in the terminal that you have opened, when I installed that Anaconda, I have two terminals. I have command prompt terminal and I have the Conda terminal.
You use
Normally,
the Anaconda prompt. You can use the
terminal.
Yeah, terminal for the Anaconda terminal because we normally two terminal we find out. One for the your computer, okay, another is for the your Anaconda terminal. So you just because we just installed all of library in the Anaconda distribution, so simply open the Anaconda prompt or Anaconda terminal. Okay, so in this terminal I simply active my library or active my conda. So simply right here conda activate
environment.
Just put the environment. My environment name is that GOAI. So I already show you that how we can really make the environment and also install the package. So just I simply open the GOAI. So because I already installed all of those. So now I just simply open my Jupyter lab in here. So Jupyter lab, just I open. Oh, sorry, I put the equal sign. Jupyter lab. Okay. So now it's open a notebook. So I open the new notebook. So just I All right, I write the code in here. It also better. Just I import the new cell. Okay, just I start from here. So now, first of all, I need to import some important library, okay, which I need to make the model. Okay, just I simply import some library to perform the analysis of linear model. So basically, we need the one library, import numpy as np. I put the name, and also import the matplotlib to display the chart. Import matplot library dot pyplot as plt. Then also import, we also put the linear regression model. So the from I put here scalar dot linear model, and import this model. It's called the linear regression. And finally, we also build the another one. It's called the score or scalar matrix. We try to check for the accuracy. So scalar dot matrix, import rs square value. So just put the rs score. Just simply import. Okay, there is no problem. It means that our all of package is successfully installed, okay, in our system. I simply imported all of those. Now take the new cell. So in this new cell, in this case, suppose I already have the NDVI value and also have the KC value for individual cropland. Okay, I already have. So in this case, I simply randomly import this type of NDVI value and also KC value. I simply import because suppose I already have this type of value. So I take a variable, suppose NDVI, and just I simply make a array. For the array, we need the numpy library. So I call the np dot array. I just make a array and store it all of NDVI value for a specific cropland. Suppose 0.23. Suppose this is my NDVI value for the specific cropland. Suppose I have the another one 0.5. Suppose I have another one 0.56. Suppose I have another one 0.68. Suppose 0.
But if I have them,
Yeah.
I have them in CSV file.
Yeah,
I can import the
same.
CSV file.
Yeah,
Is
that,
it?
yeah. Suppose I have a CSV file, all of data. I have a two column. Suppose one column is stored for NDVI, another column for the KC. So we can simply import the CSV file and then also work. No problem. Yeah, 0.74. Suppose then I put here the 0.78. Then put here suppose 0.81. Then put here suppose 0.83. So I simply imported NDVI, and now for this NDVI, for this place or for this field, what is the KC value? I simply import the KC value, all of KC value. So I simply put the KC equal np dot array, and same process I simply import the your KC value. Okay. Suppose for this first NDVI, I find out the KC value, suppose 0.20 for the first cropland or crop area. Suppose this is the potato, or this is sugar cane, or a specific any other crop. And then suppose I find out the another 0.77. Suppose I find out the another one 0.62. Suppose I find out the another one, suppose 1.0. Suppose I find out the one 1.02. Okay. Suppose then I find out suppose 0.96.
Sir,
Yeah, please.
I'm just asking the question myself, that if the aims of this model is to estimate the KC value, is it?
Okay, so in this time, this KC value we can also measure from
Yes.
our field. Okay, suppose for the specific geolocation. Okay, for the specific cropland area. Suppose I have already suppose
Yeah.
NDVI value, and same crop plan or same area, you also compute the NDVI value 0.23 or
Yes.
0.5, and same place we try to check what is the KC value. We simply measure the KC value.
Yes.
So now my target is
Yes.
that I want to predict the KC value based on the NDVI. So I make a relationship KC and NDVI. So in this case, we try
Yes.
to make the y equal to mx plus c. So we try to put y equal to mx plus c. It's called the linear equation. In this linear equation, here y is the kc value. Okay, y is the kc value. Y is the kc value, and m basically slope value, and x basically ndvi value. And I already have the ndvi. Suppose I have an ndvi map. So this ndvi map, how I can convert into kc map? So for this, we need to apply the linear model y equal to mx plus c. Here y is defend, y is defend, and x is independent. Okay, and I want to predict the y basically kc. So we can simply write y equal to suppose kc equal m multiply ndvi, okay, plus c. So now this is my target. I want to compute this equation, and in this equation I want to identify for m value and c value. Okay, from the linear model I just identify m value and c value. So further this m value and c value I want to apply on my NDVI map, and then I can easily get the KC map. Okay, so our main target is that we just make an equation. Okay, and how I can make this equation? We can just use this data, NDVI and KC data, and make the linear relation y equal to mx plus c, because m and c basically slope value and c value is same. Okay, m value and c value is the same for any data point. We find out the m value and c value is the same, but this ndvi value is the different, and if the ndvi value is changed, then kc value is also changed. So in this equation, if I know the c value and I also know about the m value, and I already have the ndvi value, then I can easily predict the kc value. Okay, I can easily predict the kc value, and this kc value I can easily, this equation I simply interpret with my NDVI equation, and I can easily predict the kc map. And from the kc map we can easily get the different information. Suppose high evapotranspiration, for the high evapotranspiration indicating about that high water demand cropland. Okay, and low kci value indicating about that low water demand cropland. We can easily get the idea from here. Okay, so now we get this equation, and now we try to compute. Suppose in this case it's independent and it's dependent. Okay, this is the independent, and independent always will be one dimension. Okay, it's always one dimension. If you check, suppose if I just print ndvi, just I print, okay, let me run it again, just run, and also print the ndvi. So again, so you find out this type of dimension array, it create the NDVI value. But when I reshape it, suppose I put the reshape value, reshape into -1 to 1, just I reshape, and now if I just run, so now you can see it show this type of dimension. Okay, so you always remember that independent variable and independent. So in this case x is independent. Okay, and for my equation ndvi is the independent, and independent of variable always is the one dimensional. And how I can make the one dimensional? Just use the reshape and use the -1 to 1, then it just show this type of dimension. And kc is the dependent, it's not need to change, we are just keep the same. If you check the kc and run it, so you can get this type of value. Okay, not need to change anything. But independent, so in ndvi is the independent variable, so that's why I simply reshape it. Okay, otherwise kc is not need, because we predict the kc. Okay, so now we simply call make the fit linear regression. Okay, so we just simply call the linear regression model. So for that I take a variable, suppose model, This variable, I simply import I already import the one model. You can say linear regression model. Just I copy and paste here. Okay, I simply call my model linear regression. Okay, so now this model I want to train with the data NDVI and KCI data. So how I can train? For the train, just call the variable name model and apply the fit function for train this model. Okay, so I just call the NDVI and also call the KC. Just I simply put the two column in my CSV file which is stored the data NDVI and KC. Just I run it. So now this model is trained, and now I can easily identify the coefficient value and intercept value. If you check, just call the model. Suppose I take a variable a equal, I call the model. From this model, I want to check the coefficient value. So just apply the function coef coefficient underscore and put the 0. Okay, so now if just run the code, so now this a value, if you check the a value, it show the one kind of value 1.45. So this is the coefficient value. Okay, or it's called the slope value. We find out the slope value, this type of slope value. So now we want to identify, suppose intercept value. For the intercept, same process, just take another variable and call your model, and from this model I want to identify intercept and run it, and also print the b value. So we find out this is the intercept value we find out in here. Okay, this is the intercept value we find out in here. So now I just simply identify coefficient value and intercept value. So now I want to check for r square value from my model, and I want to predict. Okay, so let's go try to take the another variable r square. Suppose I just call the r2 square library function and just put here the kc. Okay, kc comma, and then put here that call the model dot predict NDVI. Just run it. So now you just print the equation. Suppose print the final equation. Suppose I just write the notation. Suppose equation kc equal a, it's come from a value, and I take the 3 digit after decimal, 3 digit. Okay, this value just multiply with NDVI. Okay, and plus intercept. So I just simply define the intercept value. So it's come from the b variable, and I take the 3 floating number or 3 decimal number. Okay, so equation is simply print. Okay, just run it. So again, so you find out this type of equation in here. So you find out kc value, you can see this is the m value and this is the slope value you find out in here. Okay, this is the m value and this is the slope value. Okay, and I already have the NDVI value. So now I can easily predict the AC value. So it's one kind of equation. As well as if you want, you can also make the R value. You can just print. For the R square value, just print. Suppose coefficient coefficient of determination, coefficient of determination, it's r square value, r square value, and this value it's come from this variable r square variable, so r2 variable, and I take the first three floating number. So run it. So we find out, you can this r square value, we find out that. Okay. And if the r square value is the more strong, it means that your data set is more accurate, your accuracy is also more accurate. Okay. And if the value is the low or negative, negative mainly just we find out the vice versa. And if it negative positive value, a strong relation, we find out the strong relation if you find out the positive value. And if the r square value is the 0, it means that no relation. So we find out the strong relationship in our data set. And this type of things we can also just make a plot and display the result. So how I can make the plot for the plotting, just simply just call the plt matplotlib.pyplot as plt. I just call the plt and apply the scatter. I make the scatter of NDVI data and also KC data. Just run the code. So we can find out this type of chart. If you want, you can also make the more style. You can just make the fitted line also. Okay. So I just put here suppose color. I put the color as a suppose green color. Then I put here suppose you can also add the label. I put the label suppose label will title. You can suppose observe. Okay. And if you want, you also put the fitted line. So for that plt dot plot, call the NDVI, then just apply the model, predict NDVI. I put the color, make all red. I put the level, suppose it's a fitted line. Okay, so you find out this type of fitted line. Okay. As well as we can also add it, suppose plt dot x level and add the x level title. Suppose I put that it's a x level basically NDVI. And also plt dot y level suppose I put that it's a crop coefficient or KC. Then we just add the title plt dot title. Put the any title. I put the title suppose linear relationship real relationship between NDVI and KC. Then also add plt dot listen. You can also add the listen of the chart. And you can also apply suppose plt dot grid. Just add the grid. Just put the true of boolean operator true, and also plt dot show, and then run it. So like as we find out, this all of those is added in our title. Also add the X level, Y level title. Okay, then we can easily get the observed and also fitted line. Okay, and this is our main equation, y equal to mx plus c. So now how I can use it? Suppose I just generate this type of linear model, and now this model how I can implement on my data set. Okay, and then identify of KC map. Okay, so for that we are just come to the Google Earth Engine code editor after creating our model. Use the NDVI data and also use of the KC data. Simply use, and then identify coefficient value and also identify intercept value. So now we can simply apply.
Sir,
Yeah, please.
is it possible to export this graph as PDF or image
Yeah, it also possible
from the
Yeah.
Jupyter?
Okay. Now we can also download the PNG file format or also download the PDF file format. Okay.
Okay, and you may try maybe to show me later on when we have this data in the CSV, both two columns of KC value and NDVI.
Yes, yes.
You'll show me later.
Okay. Okay, so now we try to check how we can easily add this model. Suppose I find out this type of equation. I want to apply this equation on my model or crop field model, and then identify for KC map. Suppose this is my study area. Okay, suppose this is my study area. So I use this place different types of crop NDVI value and also KC value. Suppose I just have. So now I just apply the KC map for my place and identify which cropland need the more water demand. More water demand means that it the more evapotranspiration. Okay, and what is the evapotranspiration? Evapotranspiration mainly release of water. Okay, release of water. So suppose I find out this cropland have the more evapotranspiration. It means that this cropland area need the mass water demand. This cropland area because their evapotranspiration is very high. Okay, so it's mass more water demand is more water for this type of cropland. Okay, so let's go try to identify. So now first step is I already take the study area because I just collect some data from here, NDVI data. So you can also place any types of cropland area, no problem. So first step, we need to call a satellite data. So from this satellite data, we just simply calculate the NDVI. So in this case, it's also better. We try to apply for Sentinel-2 because it's the high resolution. We can get the more better map. So I just apply Sentinel-2. I simply search or go to the browse data catalog and then import your data set. Sentinel. And it worked for Sentinel-2 multi-spectrum experiment. And if you check, I want to work with suppose surface reflectance data. Just copy the snippet ID. So now we simply load satellite imagery. Okay, you can also apply the Landsat also, same process, or any other satellite images. I just simply import and give the variable name, suppose S2. Just simply put here filter bounds with my study area AOI, then filter depth. So I take the data, suppose year of 2024, or for the crop season area, or I put here suppose 2025 1st January from year of 2025 03/31. So I take this type of, suppose this is the crop season area, or any specific agriculture season, we simply put the time. And now filter, I want to filter suppose cloud cover ee dot filter dot less than. So just put here the image property. I choose suppose cloud pixel per sentence. Just copy the property name and paste here, and I put the value. Suppose I take the 10%. Right? So now let's check how many images are available. Around the, okay, so we find out the 28 images for this place between this time period. Okay, so now in this case, first of all, we try to identify NDVI. We just make the NDVI, and then when I get the NDVI, then I can easily apply the KC function. Okay, basically this this equation I simply apply in my model. So let's go. So how we can apply it? So in this case, I want to create the NDVI map for every image. Suppose I have total 28 images. So I want to create the NDVI map for every single images, not create the median or mosaic. I don't use the mosaic other. So I create the NDVI for every images. So how I can do it? So for that, we need to apply the function. So we create a function, or we create a tool. So this tool help you to compute NDVI for every single images. So let's go try to create a function. So just I put the function keyword, and I put the element name, suppose img, and I put my argument. What is my argument using this element? So my argument is that I want to make NDVI. To take a variable, suppose NDVI equal, if you check NDVI equal, I just put here call the element and apply the normalized difference between two band for Sentinel-2 near infrared B8 and B4, and I rename it dot rename. I put the rename as the NDVI. Okay, so I find out the NDVI. So now I want to apply this model. So in this model, if you check, we find out this type of equation. This type of equation we find out in here, but in this paper we just use this model. If you check this, there use the equation. So in this time I just take the manually value, so that's why you find out, but I want to use it. Okay, I want to use this model. But how we can easily create? Just apply your real data. So when you work with the real data, just apply this this process. Okay, then we can easily get the slope value and intercept value. So in this case I want to apply this equation, and then I want to identify for the KC. Okay, but when you work with the real data, then try to apply the same process, then we can get the more better result. Okay, so let's go try to apply this model which I gained from this research paper. Suppose in this time they are use this equation KC value equal 1.259. so this is the slope value. This slope value multiply with NDVI result. So take a variable, suppose KC equal, I just call the NDVI, and it's multiply with this value. So this is the slope value and add with intercept value. Intercept value will be 0.034. So this is the C value, and then we just put the rename function. Rename, I put it's a KC or KC. Okay. So now it's
Sir,
yeah,
sir,
please,
I have
please,
a question.
please.
I have a question, please.
Yeah.
Please. The, those NDVI values that we have used to calculate the slope and the intercept are different from these NDVIs that we have created from this image, are different. If are different, the area also are different or are value of the same study area.
Okay, so it also
You get my question?
Yeah, I got your question. So in this time, this model, linear model, it's basically not much vary for the similar crop. Okay, suppose this is your place. You can suppose this is the place. I just get the data for the suppose sugar cane. I want to cultivate the sugar cane in the other place. So I can also use this value. It's not much more difference we don't find. So almost similar value we find out. Okay, and you can also use
my
it.
question is,
Yeah.
I'm just confused with the data, the NDVI value, because this is slope and the intercept, we have got them from the NDVI value, is it?
Yes, 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 yes.
And also here in Google Earth Engine, we create the NDVI value using this Sentinel tool, is it?
Yes, 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 yes. So basically,
So
we
my question,
identify this KC value. We identify based on the NDVI value. Okay.
yes,
Yeah. So I have a NDVI map. Okay, and I already KCI value is limited. Suppose just I have the KCI value only for this specific cropland area. But NDVI value or NDVI map I find out for the whole study area from my satellite imagery. But KC value I have the some specific cropland area. Okay. So what can I do? I simply use this same area. I want to identify NDVI value. Okay. Suppose you can see in our in this notebook you can see. Suppose I have this KC value. So for this KC value, what is the NDVI value I simply gain? So what is the case for this KC value? What is the NDVI value I can gain? So for this KCI value, what is the NDVI value? Okay, I have this type of value. So now from between this type of value, NDVI and KCI, I simply make the linear model and identify for the KC. Okay, based on the NDVI. So in this case, NDVI is the independent and KC value is the dependent because KC value is depend on the NDVI value. And I already have the NDVI for all of place, but KC value I don't have all of place. So that's the reason I just use the NDVI and predict the KC value. Okay, for the whole study area or whole all of cropland area. Okay. Okay, so let's go. I just show you the result, then you get the bit better idea. So now I simply, so this equation we simply collect from our linear model. Okay, so this equation it's come from the linear model. Okay, and how we can make the linear model? So for this linear model we need the ground truth KC value and also have the end. How I can get the NDVI value? We can easily get the NDVI value. Okay, suppose if you simply make the NDVI map, suppose this is my one training sample, this is my another training sample, so I can easily extract the NDVI value for this type of place. Suppose this is my station. Okay, so I simply visited this type of point and I just stored the NDVI value or stored the KC value, okay, from the field. And then I simply come in the Google Earth Engine and further I also extract the NDVI value for this type of place and generate this type of data. Okay, for this, suppose for this KC, for this coordinate we find out this KC value and also find out the NDVI value. For the similar coordinate I find out the KCI value and also find out the NDVI value. Just we make the data set. Okay, for the similar coordinate or similar point, and further we just make the linear model, and this linear model I find out the equation, linear equation. So this linear equation we just use and predict the KC for the whole study area. Okay, all of cropland area. Okay, so now we simply apply, suppose this KC. So we are just return this image, add bands, Add bands of NDVI and also add bands of AC. Then apply the copy properties. So copy properties, this element and system type start. So now what happened if you just simply print s2 all of image. Oh, so this is the function we need to connect with our collection. So for the connecting, just use the map function. So put the dot map bracket start and close the bracket. So now run the code. So now every image it compute the NDVI and KC. What's the problem? System. No, we just use the okay. So now if you check, we find out the result. All of images compute KC and NDVI. Okay, we compute the KC and NDVI. Okay.
Oh, now, sir, I understand.
Yeah.
Now, those NDVI value we used it to calculate slope and the intercept.
Yeah.
Just some, not from all the area, but we pick only the some point, is it?
Yes.
But
yes.
in this, it means the whole study area.
Yeah. Because
Okay,
KC value is not have all of area. I have some few KC value, but NDVI is available for the all of area. We can easily collect from the satellite. But KC value is for a specific station area. Okay.
So you must have NDVI in the same area which you have the KC value.
Yes.
So in other area that you don't have KC value, that area is now we come now to estimate now from this model. Okay.
Yes. So now this model is estimate suppose other place. Suppose I don't have the KCY value for this proplan area. So then it's easily predict by the slope and intercept. Just use this linear model and then predict the KC value. Okay.
So that means it is impossible now to estimate KC value if you don't have the ground truth of some of the area of KC. You must have at least some point of KC, is it?
Yes. And this KC value we can also generate from not only for the all-time ground. Suppose you can also use some reference data. Suppose in this paper they are used at the for the individual crop. Suppose for the wheat or sugar beet or potato, they are use some data. It's collected from the food and agriculture organization. Okay, table. You can also go to the website. Then you also get the some data. For the individual crop have the individual KC value. Okay, it's the established data. You can also use it, as well as if you want you can also get some source data. Suppose Modis app, you can also get from the KC data, also get from the Modis evapotranspiration. From this type of data set you also collect the KC data. Okay, but it also better if you have the chance to collect the data from the ground. It's also more better. Or you can also use the food and agriculture tablet data. We can also get the data from here for the individual crop.
I've asked that those